Yes, this is another question on the physics. So this question is on the mechanics, particularly when we are talking about the torque of a system with respect to the moment of inertia. So that is what we are going to look at, into these questions. And then before we find the solution to this question, let's look at the question once again. A heavy flying wheel of moment of inertia 0.3 kilogram meter square. So we are given the moment of inertia to be 0.3 kilogram meter square. Then it's mounted on a horizontal axle of radius 0.01. That is the radius of the axle, 0.01 meter, and negligible mass. Don't forget that condition, negligible mass, which means mass is not considered. So mass is insignificant in that kind of a system compared with the flying wheel. Now, neglecting friction, find the angular acceleration if a force of 40 newton. So we have to find the angular acceleration. Let's call it alpha is unknown. Then if a force of 40 newton, the force given to rocks here is 40 newton, so is applied tangentially to the axle. So we have to find the angular acceleration. Now we look at these parameters. It really comprises the moment of inertia, the radius, of the axle. Angular acceleration is not given to us, and we're given the force. So we can really, apply the formula torque. That torque equals to moment of inertia multiplied by the angular acceleration. That is the product of moment of inertia and angular acceleration. And don't forget that torque is also the product of force multiplied by the radius or the distance, from the center to the circumference of that particular machine, then which must be equal to the I alpha. Can you see now? So I simplify torque here to produce FR. So my F here is equal to what? 40. The R is what? 0.01. Then I is 0.3. Alpha is unknown. So can you see now? So 40 times 0.01 give us 0.4 equals to 0.3 alpha. So we divide both sides by 0.3. 0.3. Can you see now? 0.3. So which means the angular acceleration will now be 1.33 radian per second square. So that is the angular acceleration. So we can really calculate these questions in diverse ways. Just know that torque can also be FR. So we simplify it to the simplest form. At times, it may not give us the actual value, but we need to break it down into simpler forms. So that's just it. Thank you.